I'm Chris Julian Beroya and I'm gonna present to you my topic, and it's all about smart water monitoring. First, what is smart water monitoring? It is a smart solution for water quality monitoring. It is important with advancement in communication technology out in the field of smart water quality monitoring. Also, a power efficient, simpler solution for in-pipe water quality monitoring. Based on Internet of Things technology is presented. The model developed is used for testing water sample, and the data uploaded over the internet are analyzed. The system also provides an alert to remote user when there is a deviation of water quality parameters from the predefined set of standard values. The project review. Water quality is affected by both point and non-point source of pollution, which includes sewage discharge, discharge from industries, runoff from agricultural fields, and urban runoff. Other sources of water contamination include floods and droughts. From the need for user involvement in maintaining water quality and looking at other aspects like hygiene, environment, sanitation, storage, and disposal are critical element to maintain the quality of water resources. Nowadays, water is considered as one of the most scarce natural resources on our planet. It is important to humankind, animals, and plants depending on the quality of water. It may either be a source of life and good health or a source of disease and deaths. The growing environmental degradation in recent years brought about by development, population increase, and climate change increases the need for researchers to look into its negative impact in the environment, especially in water resources and its implications. Increasing water pollution in oceans, lakes, and rivers trigger worldwide demand for more advanced methods in environmental monitoring systems, particularly in the field of water quality monitoring. Moreover, developing countries like Philippines rely on the conventional methods of collecting water samples and water analysis due to lack of technical know-how and a huge amount in the initial investments. Water analysis are usually done through conventional procedures or by using portable testers, which are not inexpensive and laborious but also lack the capabilities for real-time data acquisition, analysis, and fast dissemination of gathered information, which are crucial and essential for effective water quality monitoring endeavor. First is agriculture. Clearly, water quality is critical to crop productions. Poor quality water in general can show plants growth and negatively impact appearance. For example, water with too high pH level, which is an indicator of acidity, could be detrimental to some plants, making it difficult for them to absorb nutrients from the soil. Others are less affected by soil pH are able to absorb higher levels of aluminum or magnesium in even very acidic water. Another issue relates to salt tolerance. The nutrients plants use for development are absorbed as ionic salt. However, some plants tolerate high salinity while others will not. Irrigation water ranges in salinity. That salinity is usually measured as the electrical conductivity of water because dissolved salts in water conduct electricity. The higher the conductivity, the higher the salt concentration, depending on the type of crop you are trying to grow. A smart water quality monitoring system can help maintain the optimum conductivity level of maximum growth. Drinking water. Drinking water is typically tested for the presence of bacteria. So it's critical to examine the sterility of the water. Can it support life? The oxidation reduction potential, or ORP, essentially measures the ability of water to break down contaminants. Therefore, some municipalities use ORP sensors to measure the dissolved oxygen in water. High ORP levels indicate that the water is not capable of supporting bacteria, and so are useful in determining the overall quality of a particular water supply source. For the third case, the aquaculture. Aquaculture, or the cultivation of aquatic plants and fish, requires high quality water to promote production and increase profitability. Many facilities now use water quality monitoring equipment to measure water temperature and conductivity, two of the many factors that can affect the physical condition of aquatic animals. Optimal water quality varies by species, so the parameters will vary across the industry. Water quality parameters commonly monitored among farming systems include temperatures, dissolved oxygen, pH, alkalinity, hardness, ammonia, and nitrates. And depending on the culture system, carbon dioxide, chlorides, and salinity may also be monitored. Lastly, the water loss detection. Just about every building has an invisible network of pipes that carries water throughout the facility. For the most part, it is difficult to detect leaks in the pipes, and even when they are found, it's usually after much water has been already lost. Pipe leakage is responsible for significant amount of water loss in both industrial, commercial facilities, and public water system too. That's important not just from a cost perspective but also from a sustainability perspective. Water conservation is both good for the environment and good for business. Water flow sensors measures the flow of water throughout a pipe and its rate of change. Pulse meters are helpful in understanding the rate of normal flow and therefore present a way to detect when the normal rate changes. In manufacturing facilities, flow sensors can be used to measure the volumetric flow rate of any liquid, gas, or steam. Changes in flow rate may be an indicator of pipe leakage or other operational malfunctions, giving building managers a chance to address problems before too much water is wasted. Water monitoring quality. Water quality testing is an important part of environmental monitoring. When water quality is poor, it affects not only aquatic life but the surrounding ecosystem as well. This section and lastly, the aim of this project is twofold. The one is to provide a detailed survey of recent work carried out in the area of smart water monitoring in terms of application, communication technology used, type of sensors employed, etc. Second is to present a low-cost, less complex smart water monitoring system using a controller with inbuilt Wi-Fi module to monitor parameters such as pH, turbidity, and conductivity. The system also includes an alert facility to inform the user on deviation of water quality parameters. Thank you.